All right. Hello, hello. I'm going to run through these notes pretty quickly in case you missed them today over mass movements. So these are the mass movements that I'll briefly talk about. All right. So some things that affect mass movements. Gravity is always there. If you boil everything down, I mean, gravity is the reason that all mass movements happen. Gravity's pulling things from, a higher point to a lower point. The slope angle. So the steeper the slope, the more likely a mass movement is to happen. So, here, the rock number one, it's, really horizontal. That's not going anywhere. Number two, it's becoming more likely since it's steeper. And then number three, is still, it's steeper and the angle is steeper. So it's, more likely to happen. C, saturation, how much water is in the soil. This is a huge one. Anytime the ground is saturated and it has, more water than it can hold, or it just has a lot of water in it, either from heavy rainfall, from flooding, from snow melt. Those rainfall and snow melt are going to be the big ones. Anytime that happens, that's an increase in the chance of some sort of mass movement. The next one, something that can affect the possibility of mass movements, is vegetation. So if you look at, so here we have one container that has grass growing in it with some soil. Here has soil with leaves on top and then just soil. So you can see that, there's a lot more sediment that's been eroded into this, collection cup in just the bare soil compared to the one with the living grass. And that's because of the roots of the grass. The roots grow together and they kind of lock everything in place. So anytime there's any sort of a slope or an incline, if it has grass or vegetation growing on it, it's a lot less likely to have a mass movement. Not to say it can't happen, but it's not as likely. So the first mass movement is creep. This is the slowest type. This is something that takes tens of years, to happen. This is, 10, 20, 30, 40 years. It pretty much is a result of freezing and thawing and gravity. So if it's a slope and it freezes, it's going to expand, so it's going to push it out. And then when it thaws, gravity is going to pull it down. And then it's going to freeze and it's going to push it out. And then gravity's going to pull it down and it's going to push it out. And then gravity's going to pull it down. So it just kind of takes these steps down, but it is a slow process. An indicator of this is if you look at the fence posts, all the fence posts, instead of being vertical, are leaned over. So that's because the bottoms of the fence posts are in ground that isn't moving as much, or maybe not moving at all, but the ground above that, that's higher up on the fence post, is moving down. So if this fence post is kind of anchored there, as this ground is moving down, it's pushing that over. And because they're all moving, they're all leaning over, it's an indicator. Here's another one with some trees. Plants and trees want to grow straight up and down. They want to be vertical to get or have the opportunity to get more sun. So if you start tipping it over, it's going to curve up to get to become vertical again. So that's why they end up to be curved like that. The next one, talus. So the rock at the bottom of the slope, and it's just made up of rock, various sizes of rock and sediment that break off of rock faces higher above it. In the vocabulary, talus is not the largest bone in the ankle. It is, but that's not how we're using it. So again, during vocabulary stuff, context. There's another example of a bunch of, talus piles there, all from the rock up above. And here at Mount Rushmore, this is kind of a man-made example of talus, since it's obviously not naturally occurring, but effectively it's the same thing. Landslide. The next one is just like it says, a landslide. So this is some sort of rock, earth, soil, land that's sliding. If it were falling through the air, like rocks, that would be a rock fall, because it's falling. But this is a landslide, and these are fast. These move quickly. Another one, kind of a subset of that, a slump. So a couple of the key factors or the key things that tell you that it's slump. First off is this curve that it kind of slumps downwards. It's in the curve. It's not just straight. It's not a sheer break off. Also, that those pieces kind of stay together. We refer to those as blocks. So those blocks kind of stay together, but they move down, but they do kind of, for the most part, stay together, in conjunction with that curve. So this one is kind of, all right, I'll jump here. So this one, you can see, this pretty much stayed together, and you can also see that it's, curved. This one, it didn't stay together as well, but there is still that curve there that everything just slid down the curve. An avalanche, breathe easy. Don't lose any sleep over this. This is not something that we will ever have to worry about in Indiana. We don't have mountains and we don't have enough snow. So avalanche is anytime snow and anything else that it picks up as it moves down a mountain, is falling down a mountain, basically. So you end up with snow, ice, rock, soil, trees, anything else that's there, buildings. It's snow that, can't hold where it is, and it breaks loose and falls down, travels really, really fast. It can do a lot of damage. Let's see, the next one, the fastest one, mud flow. The reason it's the fastest is because it has such a high water content. It's obviously going to be thicker than water, so it's not going to flow as fast as water, but it's pretty close. These are very fast. These are, often there isn't a lot of warning that this is going to happen, so you can't really plan for it or get away from it. And they can be extremely deadly and extremely dangerous. So here we have just a picture of some, an aftermath of this. And once the mud stops moving and some of the water kind of drains out of all that, then it kind of just becomes, more solid, more and more solid. So it's really not easy to clean up either. So these two cars were pretty lucky to still be on the road. Use the term mass wasting just to kind of include any kind of damage from these things. So, it can be, to buildings or cars or, whatever. It's just kind of a general term though. And there's a couple of video clips there. You can check those out if you want. And then here are just a couple of examples of things that are done to try to protect, especially roadways, from falling rocks. And these are essentially chain link fences that, when we see chain link fences out places, they're pulled tight. But if you don't pull them as tightly, and it allows for there to be more give and more spring, so they have the strength to stop some rocks. I'm not saying they stop all of them, but they stop some rocks and can protect roadways from falling rocks. So I hope that helps a little bit with some mass movements. So have a good day.